freecoachingtoday.com.
So we will now study an important practical trick for that is useful in adding two or more vector. We call it resolution of vectors. We have already seen that we can add two vectors and find a resultant vector. It's also possible to express a given vector. Let's say this is an OA vector which makes an angle theta with the x-axis. We draw a rectangular coordinate system, x-axis and y-axis. We want to express this OA vector as the result of two vectors. One vector is along the x-axis, other vector along the y-axis. So we draw a perpendicular from this point A on the x-axis. Let's call it OB, and we draw a perpendicular from A on the y-axis. We call it A. The foot of the perpendicular is, let's say, C. You can see that this OA vector can be expressed as the sum of OB vector and OC vector. We write it as OA vector is equal to OB vector plus OC vector. So we have resolved this vector OA vector into vectors OB vector and OC vector. That's a very simple thing. All we do is, what's the magnitude of OB and what's the magnitude of OC? The magnitude of, let's say the magnitude of OA vector is A, then the magnitude of OB vector is A cos theta, and the magnitude of OC vector, this is going to be A sin theta. So we can express OA vector as A cos theta into I vector, where I vector is a unit vector in this direction of x-axis, and then we call it A sin theta into J vector, where J vector is the unit vector along the OC vector direction. What is the use of this resolution? Very good question. and it's also not necessary that you can resolve only in x and y direction, perpendicular direction. You can resolve it in any two directions that you want to. Any vector can be expressed as a sum of two vectors. But resolution along the x and y perpendicular axis provides some practical benefits in addition of two vectors or more than two vectors. How do we add? Let's say how we add three vectors using the resolution of vector. Let's say I have one vector like this, another vector like this, and the third vector like this, and we are given that we put it in the coordinate axis to make the thing simpler for our calculations. Let's say this is vector P1, vector OP1, vector OP2, and vector OP3, and they have lengths of, say, let's say this is L1 length, this is L2 length, this is L3 length, and they make an angles alpha 1, alpha 2, and alpha 3 with the x-axis. So how do we express P1 in terms of the in terms of the resolution of vector? We can write OP vector as L1 cos alpha 1 multiplied by I vector, which is the unit vector, plus L1 sin alpha 1 multiplied by J vector. And similarly, this is OP2 is L2 cos alpha 2 times of I vector plus L2 sin alpha 2 times J vector, which is again a unit vector. OP3 vector is L3 cos alpha 3 into I vector plus L3 sin alpha 3 multiplied by J vector. Now we have a set of three vectors along the x-axis direction, and we have a set of three vectors along the y-axis direction. 1, 2, 3 vectors. Now adding these 3 vectors is the same as adding these 6 vectors. 3 vectors along the x-axis direction and 3 vectors along the y-axis direction. So the sum OP vector is equal to OP1 vector plus OP2 vector plus OP3 vector is the same as the sum of these 3 vectors and the sum of these 3 vectors. And what is the sum of these 3 vectors? These are these 3 vectors. That is L1 cos alpha 1 plus L2 cos alpha 2 plus L3 cos alpha 3 multiplied by I vector plus the sum of all the vectors along the y-axis direction, which is L1 sin alpha 1 plus L2 sin alpha 2 plus L3 sin alpha 3 multiplied by the j vector. With this, what it does is that it simply expresses this set as a set of x-axis vectors and a set of y-axis direction. We add all of the x-axis vectors and a set of resolved y-axis direction. This is, and from there we can find the magnitude. The magnitude is simply, let's say the x-axis sum of direction comes like this. Let's call it x1, and the sum of y-axis, this thing comes at y1. Then we can find the result. The magnitude of the OP vector is expressed as square of this plus square of this. I will leave it as an exercise. It's simply just you can write this whole term here and this whole term here and square it, this thing, find a square root, you get the resultant magnitude. Also, the more important thing is that it allows us to find the direction of the resultant vector. Let's say this is OP is the vector is the resultant vector. And if it makes an angle theta with the x-axis, and we can represent this tan theta as this y, the length of this one divided by the y-axis, the sum of the y resolved component divided by the sum of the resolved x-axis component. Then this magnitude we know is L1 sin alpha 1 plus L2 sin alpha 2 plus L3 sin alpha 3. I write it down quickly. L1 sin alpha 1 plus L2 sin alpha 2 plus L3 sin alpha 3. And I write down this magnitude quickly as L1 cos alpha 1 plus L2 cos alpha 2 plus L3 cos alpha 3. And this tangent of this angle theta is given by this distance divided by this distance, or L1 sin alpha 1 plus L2 sin alpha 2 plus L3 sin alpha 3 divided by L1 cos alpha 1 plus L2 cos alpha 2 plus L3 sin alpha 3. You can see the resolution of vector helps us to find the sum of one or two or more than two vectors in a more elegant way. If we had used triangle law, it becomes complicated once you add two or more than two vectors.